stage is yours.
Thank you, and welcome to this presentation of a practical endgame on issuance policy, which is also the title of my recent ETH research post. And we begin in a hypothetical future scenario, perhaps a decade from now, where the cost of staking has come down and staking frictions have been overcome. Now, people still have different perspectives of the cost of staking and stake under varying conditions, so there's really no agreement on the exact yield that is sufficient for staking. People have different reservation yields, that is, the lowest yield they find acceptable for staking. They are at this point indifferent to staking or holding the token. Let's plot the hypothetical distribution of reservation yields. We see here we have staking yield on the x-axis and we have amount of stake on the y-axis. A few might be willing to stake at a negative yield, perhaps to attack or defend Ethereum. Many more are willing to stake as the yield becomes positive, and at 1% staking yield, perhaps a lot of token holders rush in. In this hypothetical scenario, at 2.5%, half the ETH is staked, and as the yield reaches beyond 4, 5, or 6%, not much more stake comes in, because almost all ETH is already staked. And we can explore this further by computing the cumulative stake, here in blue, as it rises to 1. The cumulative stake can be referred to as the deposit ratio, that is the proportion of all stake that is deposited for staking. And we can also call it the deposit size. Then we are referring to the quantity of stake, the total, reaching 120 million if all ETH is staked. Now let's remove the negative part here of the yield and flip the axis. And we have now created from a distribution of reservation yields what we generally refer to as the stake supply curve. So if you remember, at the 2.5% yield, half the ETH gets staked. We add also the demand curve specified by the protocol. And let's add also 300K of MEV each year. We then reach at the intersection of demand and supply what we generally refer to as the staking equilibrium, at the black square. But currently we are here, and the supply curve isn't exactly known to us. So that's the situation we have right now. We are now ready to discuss the motivation for a reduction in issuance. If you note that over half the circulating supply could be staked in a plausible scenario, but there's general agreement amongst researchers that 30 million ETH is perfectly sufficient for retaining security. And here we would be at more than twice of that. Zoom in on this range here. What's the cost? Why don't we want to pay more for security than what is strictly needed? Well, for one, we can approach cost rather generally, speaking of, the hardware that you need to pay, the taxes you need to pay for, you have illiquidity, you need to finance the upkeep of your software, etc. And it's then natural to approach the cost as the reservation yield. If you remember, that's the lowest yield at which you are willing to stake. And then, since the supply curve captures the marginal reservation yields, as shown previously, you can compute the total cost for staking in aggregate for the protocol as the integral of the supply curve. And so in this scenario, there's a picture. Oh. Can I remove this? Yeah. And so in this scenario, the total cost of staking becomes 820,000 ETH for this specific supply curve. That's $2.6 billion. There's also a surplus above the supply curve. So the marginal staker with the low reservation yield will have a high surplus, and the marginal staker will have, with the high reservation yield, will have no surplus at all. Let's now reduce issuance with the red reward curve. This then pushes down the staking equilibrium down to the red circle here. This gives us a cost reduction benefiting all token holders. So we're removing essentially hardware cost, taxes, we're removing illiquidity for users and the risk premium, and benefiting all token holders in the form of a lower amount of newly minted ETH. And that's around $1.4 billion at the current token price we would save in this hypothetical scenario. There's also a surplus shift from stakers to all holders. But this just shifts value around from one set of users to another. The cost reduction, that's the welfare gain we're striving for. And it's a wonderful opportunity we have here to reduce the cost of our users. A simple way to frame it would be, don't buy things you don't need. This is not a sustainable model. And we, of course, need to focus on facilitating sustainable economic activity. Now some people will say, well, the yield makes Ethereum attractive. It's fun to stake. But we have to remember that all ETH that is issued will also dilute the token holders. So there's nothing gained, in the aggregate. We shouldn't try to trick our users into believing so. We need to focus on facilitating sustainable economic activity. Or some people say, well, we need inflation, otherwise people just hoard the tokens. Well, that's not true. First of all, consider the fact that if you issue a high amount of token, then you compel users to lock up the token staking instead of having them available on hand, for paying your transactions. Furthermore, consider the fact that, of course, if you focus on what we are trying to do, the need to transact is universal. It's not really affected. And if we ensure that Ethereum facilitates sustainable economic activity and that ETH remains sound, then the best option available to users is to be on Ethereum transacting using ETH. And so that's what we have to strive for. And then some people say, well, apps rely on the yield, framing the yield as somehow productive. It's not. And it's not our role, unfortunately, to support applications that do not facilitate sustainable economic activity. That's not our job. And if we do so, a high issuance will always over time turn into perverse subsidies. There's also a macro perspective to consider. High stake participation puts pressure on the consensus layer. Here we have the current scenario, around 35 million ETH staked. But imagine a scenario where almost all ETH is staked, and then something breaks. Say there's a discouragement attack, the censorship, or there's some client bug or anything else. In this scenario, Ethereum relies on the social layer as a final recourse. But what happens if the social layer is sort of wrapped up? Everyone has stake in the game. Well, in this case, the social layer sort of becomes overloaded. And we have come to a point, where we can lead to very aggregated failure modes. We would then very much prefer the bottom scenario, where we have a neutral social layer available. High stake position also can lead to, of course, higher attestation load. And furthermore, it put pressure on the app layer when one or a few LSDs comes to dominate this money. Ethereum then is deprived of a trustless sound assets, which is one of the most important, crucial features of a decentralized blockchain. And you can imagine if you have control of the money, you sort of can control users and apps in various ways that we wouldn't really like. Furthermore, consider the fact that if apps build on top of the LSD, and then apps build on top of the apps building on top of the LSD, and you're creating this sort of monolayer, and then something breaks, then you are sort of threatening the whole system here, which is something we really would like to avoid. So in conclusion, even though nominally the protocol might seem maximally secure if everyone is staking, it turns out that it's actually a bit insecure, both at the consensus layer and at the app layer. And we would prefer the bottom scenario here. However, there are also potential downsides for a reduction in issuance. For example, pseudo stakers do not have the economies of scale of large staking service provider. So it's perfectly possible that a relatively fewer pseudo stakers might be willing to stake in the scenario where the yield falls very low. There are arguments in the other direction as well, but still, let's explore this a little bit. So we go back to the first plot of reservation yields. And let's split up these reservation yields into two classes. We have delegating stakers and we have solo stakers, so loosely defined here. Now, there are more delegating stakers than solo stakers, so I'm just normalizing these two plots as well. So one scenario is that if we lean on economies of scale, is that the reservation yield among delegated stakers might have a peak in the distribution a bit lower, say at 1%, whereas the peak for solo stakers is at 2%. Well, in this case, we would indeed see that the proportion of solo stakers at the lower issuance yield would be slightly lower. The argument in the other direction is that at a very high stake participation, and LSD comes to dominated money, so there's no loss in liquidity if you own the LSD. Big staking service providers also get better economies of scale, and it may be perceived as that the risk of staking with them falls because they become, too big to fail. There's no social layer there anymore. So that's a counter-argument, and that could happen at any yield depending on the exact shape and slope of the supply curve. MEV also becomes a much bigger concern for us as lower issuance. It increases solo stakers' relative yield valuability, because they cannot effortlessly pool their rewards. Furthermore, it degrades the incentive to attest properly, since MEV will be the only thing that counts. So there's a lack of incentives to attest, and we can then consider various ways how to resolve this. We can try to increase the attestation penalties. All right, so now we increase the attestation penalties. But then, if you are a staking service provider and you drop attestation of your competitors, then you can sort of force them out. So then we have to have proposer penalties as well. All right, now we added proposer penalties. But then if you're a solo staker and you make one bad proposal, you can get punished very hard because we have lowered the issuance as well, And you might be in the red for several years. All right. And so then there are ways to try to soften this, but there's a lot of things going on at the same time here that we're working on. And it also further complicates the design of Orbit SSF, the single slot finality design, because then there's also a way for stakers to avoid having to attest as much as possible, taking as low risk as possible. And so the lack of incentive to attest can then lead the stakers to deconsolidate, and then we need to raise the consolidation incentives, and this can, of course, further raise fairness concerns. And what we would like to ship is MEV, because this reduces all these three issues. So that's something that is really important for Ethereum, but we don't have it, and we have to deal with the situation we have. We're now ready to discuss a practical endgame on issuance policy. So here we have the current reward curve, with issuance rising all the way up to 1.8 million ETH with the current reward curve. Here we have the red reward curve shown earlier. It forms by taking the equation for the current reward curve and adding the cube deposit size to the denominator. And I refer to this as a practical endgame. It's practical because it's something we can strive towards without MEV burn. It's practical because we should be able to guarantee solo stakers to not have to pay for staking. And it's practical because it allows us to design consensus incentives in an easy way. And it's also practical, and it's an end game because it allows us to probabilistically stop the growth in stake. So that's why I favor the red reward curve, or something close to it. This shaded range is approximately where I would like to be. That gives us room for a higher or a lower reward curve, depending on how the design works out, the feedback from the community. Others might prefer different ranges, perhaps focusing on stopping the growth in stake or increasing the yield for solo staker. And this can be discussed. But if we go too high, you can imagine if we say go to 110 million each staked and provide anything about the bare minimum to avoid solo stakers paying, then this would feel like a misbalance of these different trade-offs we're trying to balance. And then there might be a movement to further reduce issuance. And we would like to make one singular change to issuance policy. And that's why I find that this will be slightly above where we want to be. And you note that none of the reward curves nor the shaded range goes above an issuance rate of 0.5%. That's sufficient to ensure security, and it's at the upper end of any trade-off I think we should ever consider. So regardless of the exact endgame that we choose, we could safely commit to never issuing more than 0.5% of the circulating supply each year. And it feels like a rather attractive proposition, you know. Tell your friends, choose Ethereum, choose ETH. There will never be more than 0.5% of the circulating supply issued each year. And a cap on issuance is perfectly viable on insurance security, whereas a cap on the circulating supply is not, regardless of if you are in proof of stake or proof of work. And from my perspective, we could just chip, you know, 0.5% cap, solidifying it, and then come back to this in a few years. But there seems to be, from the community perspective, we want one single change. So that's not something I would push for. There are other ways to construct a reward curve. I'm showing here other alternatives in the ETH research post, like sigmoidal shapes, for example, with the equations provided there. Let's now look at the impact of an issuance reduction on stakers. We have here the staking yield, and we see that we are showing it with MEV. Now we add the supply curve, and we are able to reduce the equilibrium from 60 million down to around 40 million staked. But of course, we are here, and so given some reasonable supply curve, we might end up in this region here. We must also consider a very low supply curve and what might happen in this scenario. And here we have that bad situation for the macro perspective, when almost all ETH is staked. And we could then bring it down to around 65 million ETH with the red reward curve in this scenario. And of course, shipping MEV burn as well, we come down to almost 50 million ETH staked. And it might seem like a bad scenario, but it turns out that it's actually better for a staker to be at the red square there than at the black square. And that happens because of this equation. It's from my post on minimum viability that sort of started this whole conversation. And it captures the attainable change in the proportion of the circulating supply. So it's sort of like a proportional yield, or it's been referred to as the real yield, or the change in ownership. We have the yield that you attain on top of the fraction line, and we have the inflation rate at the bottom of the fraction line. That could be negative, you know, if there's a high burn rate, but otherwise positive. And we can use this equation to draw something I refer to as isoproportional lines. And at these lines, across these lines, the proportion of the circulating supply that you attain remains constant. So it doesn't matter if you're at 1.5% yield, 2.5% yield, or 3.5% yield. From the perspective of the stakers, once you account for dilution effect, if everyone almost stakes, you get the same proportion of the circulating supply. Let's draw more of these lines. It's like a topographical map, you know, with counter lines indicating equal elevation. So, at this map, you want as a staker to be as a high elevation as possible. This equilibrium at the red area here is not so good, even though the yield is high, because you're at low elevation. Any equilibrium above the dashed curve is at a better, higher elevation. So the orange area here is better for you as a staker, even though the yield is lower. And here we have the supply curve from previously. And we see that if you start here at the black square, you have 110 million ETH staked and say a 1.8% staking yield. Well, it might feel good as a staker, but you follow this as a proportion line all the way to the other equilibrium that's possible under the supply curve. And you see that you're equally well off as a staker at a 0.25% issuance yield and 20 million staked, because you're not suffering from dilution. And the optimal situation here is actually at this red square here, where you're at the highest elevation as possible on the map. But this is just surplus shifting around. It's not the motivation for issuance. The motivation is for an issuance reduction. The motivation is the cost reduction. But it's important to understand this as well. It's very important to emphasize this. And just as a concluding remark, a checklist on the practical area and what needs to be done. There needs to be a theoretical foundation, and we have shipped it. There's a cost reduction, and there's the macro perspective. We need to have curve parameterizations, and they're available in the post and elsewhere. We need to design Orbit SSF consolidation incentives. And I posted yesterday a post on that. So I would put it as yellow because it's a draft post, but it sort of outlines approximately where we would like to be. We also need to redesign Ethereum's consensus incentives a bit if we push issuance yield down close to zero. And we have been working on this a bit, but as you noted, the discussion about different incentives, but there's a few things, quirks to work out. So I put it orange. If we push method burn, both of these becomes greener because, then the issue isn't that big anymore. I'm also working on a probabilistic equilibrium analysis that I will post in the first quarter of next year. And that will, I will put it at orange. And that would be like a foundation for my perspective of why we can do it from the perspective of decentralization. And we also need to build community support. And I will put it at yellow. By turning the other check marks green, we can also build community support better. And we build community support, of course, by striving for an Ethereum that facilitates sustainable economic activity. That is what we're working on in all these different parts of the roadmap. That is how we strengthen ETH and Ethereum, and that is a suitable North Star, in my opinion. Thank you.
Thank you so much, Anders. Now time for questions. The first one, what do you think about reward curves with dynamic parameters?
Yes, I have written about this actually. There's a FAQ, and I talk about the issue. If the question relates to the issue of trying to dynamically adjust the reward curve, the point is that it's not a way to address the issues that we have in the long term. In the long term, it doesn't matter, We need to focus on the one reward curve because that's how we prioritize these different aspects, So I think that there's the idea of, having some dynamic solution. There's a threat in it that you think that you're solving something, but you're not solving it. You're not solving it in the run. The only reason why we would like to have a dynamic curve is if we go back here. But if you have an equilibrium where you have to lower the issuance yield so much in the beginning, then, of course, and I describe it a bit in the FAQ, then, of course, you could consider a scenario where you have, you tick down the reward curve gradually over a year, so that you don't make people lose the staking yield so quickly. Making it becomes very bad effects on everyone if you just shock it, because otherwise the assumption is, of course, that some are going to leave, so the yield is going to go up again. But if you shock it down and then the yield becomes very low, there's a risk that the solo stakers are going to leave before the yield comes up again.
Next one, how does the Beam Chain proposed roadmap affect progress on issuance policy?
Well, so my interpretation of how it affects is that it's essentially something that is sort of part of the idea is that we try to ship issuance policy as one of these gradual improvements. It's not like part of the Beam fork. It's supposed to be done earlier. So I would say that it's sort of part of the overall roadmap there. Yeah.
Thank you. What would you say is a good governance process to agree on a new issuance curve?
Rough consensus.
That was a quick one. Why does MEV burn affect our need for consolidation incentives in Orbit SSF?
No, it's not MEV burn that affects it, it's MEV. So if you design Orbit SSF, like a basic idea of how you can design Orbit SSF is that you push out smaller stakers so that they don't attest as frequently, while you at the same time give them the same yield. So it's sort of fairness still. But the situation is such that if you push out them from attesting, you cannot at the same time push them out from proposing. That's a lot of bigger concern, because if we still have MEV, in the situation. Then we cannot make it fair. If we push down the issuance, and then you still gain a lot of the value. You gain almost all the value from proposing and attaining this MEV, you know. There's no MEV in place. Then everyone would like to be deconsolidated to remove risk, but they still get to propose as often as today. And so that's an issue.
Great, thank you so much. The next one, we still got more time. Is there a yield where you might expect institutions to lose interest in staking or might find alternatives to generate yield? Long question. Does it compete with some traditional financial yield threshold?
I mean, the beauty of having a reward curve is that if there's a loss in interest in staking in general, the yield goes up, you know. That's the whole principle. So, I mean, it's hard for me to consider. The option would be here, maybe implied, is that everyone wants to stake, but no institution other than one or a few are still willing to provide services. And I find it a bit perhaps tricky to contemplate that this would be the case. But of course, we have to allow various institutions to compete. You know, we cannot avoid that there's going to be a competition. We would like, of course, for there to not be, but it's not something we can avoid.
Should we go for the last one? There's no vote, but I think since it's already here, let's answer it. There's already so much financial investment by influential VC-funded actors, even at current levels. Do you think it's possible to make a change that drastically affects their bottom line?
Yes.
Okay. Can you a little bit more about the yes? Why, do you think?
Well, I don't know. I don't think that VC-funded actors is like the biggest issue for us. I mean, the biggest issue, of course, is if solo stakers would feel like it's a disappointment for them. So VC-funded actors is the least of our concerns, I would say, in this regard.
Great. Our time is up now. Thank you so much.